Today we will start with lesson 12, but first let's download the examples of this lesson. So we are using wget as usual. And then with tar, we are extracting the archive of examples. Okay. Today we will start with while loop. The while command in Bash looks like this. While commands do some other commands, and then done is closing the while cycle. So let's write a simple script that uses while. So this is going to be a Bash script. And I'm writing a comment here that explains what we are going to do with this script. Actually, we are going to we want to display the numbers from 1 to 5, for example. And let's keep count and initialize it to 1. Count variable and initialize it to 1. And now I will start the while cycle, while the variable count is less than or equal to 5, do echo count, and then we want to increment the count by 1. Then we close the while loop. And we display just this message finished. Let's try it. So the count initially is 1, and we check here whether it is less than or equal to 5. It is less than or equal to 5, so this body of the loop is going to be executed. Echo the value of count, which is 1, and then count becomes 2 because it is increased by 1. And then we go again and check the condition of the while. So this is a condition which is similar to the condition of the if command. So either it results with a success or with a failure. And we are checking the value of this variable, whether it is less than or equal to 5 2 is less than or equal to 5, so the cycle will be executed once more. The body of the while will be executed once more. We'll print 2, and it will be incremented by 1, and so on until count becomes 5, until count becomes 6. When count becomes 6, this test is failing because 6 is not less than or equal to 5. And because the test is failing, the test of the while command is failing, then it will not continue with the execution of the body, but it will be finished. It will be done, and then the execution will continue here with the last command, echo finished. We can also use the arithmetic construct for testing here, and in this case we don't use a $sign. We don't have to use the dollar sign in front of the variable, and we can use this arithmetic comparison operator, and the result should be the same. Yes, it is the same. Now we have seen an example with a menu in the last lesson, in lesson 11. So we have this example with the menu here. Let's copy it and modify it and try to make it better, to improve it, to make some improvements. So let's remind again what it does. It is displaying a menu and with some options, and we can select one of these options, for example, to display this space, and it is going to display this space, and then it will terminate, it will finish, the program will finish. And then we have to start it again in order to make another choice. It would be better, or it would be more convenient that we use a loop to execute it again after we make a selection, and we want to execute it repeatedly until we press 0 for quit, and then to terminate. So let's modify, or let's improve this program to do this. So we want a while cycle here, and we will write some condition here, and then do, and then at the end of the script we are closing the while with done, and I am saving it. And to make it more readable, I'm going to improve the indentation by moving these commands, by including some spaces. So I am typing MA. I am placing a mark in this line, mark with letter A in this line, and then let me go to the last line, to the line before, and then from the line that is marked with A up to the current line, substitute beginning of line with 4 spaces. And so I moved them to the right with some spaces, all the lines in order to make the program more readable. This is echo here. Anyway, now something wrong. Okay, let's have that it is displayed better. So I'm reading a selection here, and it will be read to the variable reply. And I want to repeat this cycle until reply has the value 0. So this is the testing condition that I will place here to the while. While reply is different from 0. While reply is different from 0, repeat the cycle again. This clear will clear the screen, and then this echo will display the menu options, and then we will read another value for the reply. And then instead of exit, I want to remove this exit because this exit will terminate or will finish the execution of the script. Instead of exit, I can type continue. Continue will force the execution to start at the while again. So it will not continue doing the rest of the body of the while, but it will start again at the top. We'll check the condition again, and then we'll continue again. So this command continue inside the while cycle will stop the execution of the rest of the body of the cycle while, and it will start at the top again. So if reply is equal to 0, then echo, okay, we don't need this part because we are checking whether reply is equal to 0 at the top of the while. So I'm deleting this part. If reply is equal to 1, then echo hostname is this one. The command uptime will show the information that is the system uptime, and then again continue. We'll stop executing the rest of the script, and we'll start at the top. At the top of the while command. And again, the same logic applies here. Continue. And here we may write continue or we may not write continue. It doesn't matter because this is the last thing before the loop is closed. So it will start at the top of the loop again. So let's try and see what happens. Please select display system information. Let me type 1. Display this space. Let me type 2. It seems like it does not do anything at all, but actually it does but it does it very quickly. And so we need to add some delay before the menu is redisplayed again. So after some uptime shows the information about the system, we need to add a sleep. For example, sleep 3 seconds. It is going to wait before it continues and at the top of the while loop and displays the loop again. And again, after each command, we had to have a delay, to add a delay. And here we can add the delay at the end. Sleep. So let's test it again. It is displaying the information from the command uptime. It waits for 3 seconds, sleep 3, and then the execution will continue at the top again. Let's try with 2, display disk space. Let's try with 3. And let's try, for example, with some invalid value. It does not accept it, but it should give an error message. So maybe we should fix it so that it shows an error message. Oh, we need to have a delay after the message invalid entry. So we need to have a delay after this message as well. So let's try with 5, invalid entry, and then the menu will be displayed again. So with 0, we exit from the menu. Instead of while, we can use until. Until is very similar with while, but the test condition is reversed. So let's write an example with until. So until we have some testing, and then do, and then at the end, done. This is the syntax of until. This is how until is used. But first, let's declare a variable count and initialize it to 1. Now, until count is greater than 5, until count is greater than 5, do echo count, and then increment count by 1, count, and then echo finished. And let's test this one. So the difference with while is that with while we are using the condition count less than or 5. So while count is less than or equal to 5, do this stuff. With until, we say until count is greater than 5. Or if we write it with arithmetic expression operator, it can be written like this. So let me write again the condition with while here so that we can compare it. So I'm commenting this out, and while count less than or equal to 5. So with while we use this condition less than or equal to 5. With until we use the opposite condition, count is greater to 5. We can use while and until to read some lines from a text file instead of using the command read. And let's see an example with this. We have here the examples. This file distros.txt that we have seen before as well. And in the script, in this example script, while read, we are reading lines from this text file and then with the command read. So here we have while, and then this is a command. This is the command read, and it is reading values into these variables: distro, version, and release. And this is starting the body of the while. This is the end of the while. And what it does in the body is this command printf, print formatted, or print with a certain format. And what it prints is this string or meta string. And in this string, this percentage s is replaced by the first argument. The second percentage s is replaced by the second argument of this string, and the third one is replaced by the third argument, which is the variable release. And this is a tab. \t is a tab, and this is a new line character. \n is a new line character. And we are using this backslash before the end of the line in order to continue the command. So this is telling Bash that this command is continuing to the next line. And then again, we continue the command to the next line. And then with this backslash again, before the end of the line, we continue the command to the next line. And this is done for better readability, to make it more readable. And the command read usually reads from the standard input, but here we are redirecting standard input to get the lines from a file, to get the lines of a file, to get the lines of the file distros.txt. So the standard input of the command read is actually coming from this file. And so it is reading the first line. It is reading the first line from this file, and it is splitting it by spaces, tabs and spaces. And the first part is saved into this variable. The second part is saved into the second variable. And the third field is saved into the third variable. And then these are printed with the command printf. After this is done, it will continue to read the second line of the file and do the same thing. It is going to read the third line of the file and do the same thing. And it will this cycle will continue until a read command cannot read anything until the end of the file. At this moment, the read command will fail. It will not be executed successfully because there is no input. We reach the end of the file and there is no input. The command read will fail. At the moment that this command fails, then the while cycle is broken because this command is not executed successfully. So let's test this script. So it is displaying this formatted line. This was the %s, and there was a tab here, and then here there was another %s, which was replaced by the version, and the third %s was replaced by the third variable. So we have here distro colon and then %s, and then a tab, and then version column %s, which is replaced by this variable, and then a tab, and then released column, and then %s is replaced by printf with the value of this variable release, and then a new line. Let's see another example, which is similar to this one, but is a little bit different. In this case, we again have a while loop and a read command, and then a printf command inside the body of the loop, and then it is closed here. But in this case, we are taking the input, the command read is getting the input from the pipe, from this pipe. So in the first example, we were redirecting standard input from a file. In this case, standard input is coming from the command that is executed before the pipe. And the command that is executed before the pipe is this sort. It is sorting by the first column as the key, and then it is using the second column as the second key. And it is sorting it numerically. So this can be any command. For example, this can be the command cut to output the command or to output the content of this file to the standard output. But in this case, it is a sort because we also want to sort it using these keys. So let's test this script as well. And now it is the same information, but it is sorted by the first column or the first key, and then the second key, the second sorting key is the second column, and it is sorted numerically. If we use, for example, instead, if we use cut instead of sort, so I'm commenting this out, and I can just use cut, for example. Then the content of the file will be in the same order without being sorted, in the same order that is in this file. So the three last ones are this, and the three last lines are this one, which are the same. So let me comment this one and uncomment the original. Now we will see another command which is similar to if. It is called case, and it does the same job that if does, but in some cases this is more efficient and more easy to read and nicer. So let's see an example with case, and we will modify the menu program so that we use case instead. So so first of all, we clear the screen, and then we display a menu with some options. Display system information. The second option is display disk space. The third option is display home space utilization. And the option 0 is to quit. So after we display the menu, we are going to read the input. Read with this prompt. Enter selection from 0 to 3. And it is going to read it to the variable reply. So this is where the input is going to be read, because we are not specifying a variable, or we can specify a variable answer, and then the input will be on this variable answer. And now I'm going to use a case command, case answer in. So if it is a 0, then just echo program terminated. And then exit. And then we are closing this case with this double semicolon. So in case that the answer is equal to 1, echo host name, the environment variable host name, and then the command add time, and then we are closing this case with this double semicolon. If answer is equal to 2, then just dfh, the command dfh, and then we close this case with a double semicolon. If answer is equal to 3, then we have to okay, let's keep it simple. Echo home space utilization, for user then we use the command disk usage with the option -h, which is human readable, for the directory home. And then let's close this case with a double semicolon. And then this star is matching anything else. So star matches anything. So it means that if answer is something different from these options, 0, 1, 2, 3. In this case, we output the message invalid input or invalid entry. And we output this message to the standard error. And we exit with an error message. And then again, we close this case. And finally, we close the case command with this exec, which is a case in reverse. It is similar to if. Similar to if, we close it with phi. It is just a syntax, similar, for example, to parentheses that are symmetric to each other. So let's test this. Change mod +X to make it executable, and then menu. Display system information 1. Display this space 2. Display home space utilization 3. 0. Program terminated. Notice that we could have done this checking, and we have done this checking with if, else if, and so on. But with case, this is more compact and more easy to read, and it looks nicer, and it is easier to understand that we have several options. This double semicolon is used to stop processing once we get a match. So if answer is a value, if this value is 0, then this option will match. And once these commands are executed, we will reach this double semicolon, and the processing will stop. It is not going to check the rest of the cases. If instead we want to check the other cases as well, so this case, it does match this case, but probably it is going to match the other cases, one of the other cases, then we can use we can append one ampersand after the this double semicolon. So let's see another example with that does this. It is this example here, case patterns. So here we are reading something with this prompt, enter word, and we are inputting some word. This is going to be saved into the variable reply, and then we have these cases: one case, the second case, the third case, fourth case, and the last one. So it is going to match the content of the variable reply to this one. This is an alphabetic character. So if it is a single alphabetic character, then it is going to match this case, and then it will display this message. It is a single alphabetic character, and then it will stop. It will stop processing. So the other cases will not be matched. Otherwise, if it is not an alphabetic character, then it is going to try the second pattern, and this pattern is one of these characters, uppercase A, uppercase B, uppercase C, followed by one digit from 0 to 9. So if this pattern is matched, then it will display the message, it is A, B, or C, followed by a digit. And then processing will stop. Otherwise, if it does not match this and does not match this, then it is going to try this pattern. And this pattern is 3 characters. So if the reply has 3 characters, then it is going to match this pattern, and it will display the message. It is 3 characters long, and it will stop. Otherwise, it is going to try the other case, which is star.text. And notice that this one and this one are the matching that is done by the shell to match the files in the current directory. So if it matches this pattern, then it is going to display the message. It is a word ending in .text. And this is a wildcard matching. It will match anything else. So if nothing is matched up to now, then it will definitely match this one, and it will display the message. It is something else. So let's try this example. Enter a word, X. It is a single alphabetic character. Now let's try it again. Enter a word, A2. It is A, B, or C followed by a digit. Let's try food.text. It is a word ending in .text, which is the third case. Let's try XYZ. It is 3 characters long. And let's try AB. It does not match none of the cases above. It is going to match only the last case. So the wildcard case. So it is something else. The message that is displayed is it is something else. Let's see this other example. Case menu L. It is a menu-driven system information program, similar to what we have seen before. Clear will clear the screen. Echo will display these options. But notice that in this case, we are using letters instead of numbers, letters A, B, C, and Q for quit. And then here we are reading an input with this prompt, enter selection. The input will be saved in the variable reply, and so we are doing a case here with the variable reply. And let's see the options of the case. So here we are matching a Q or a capital Q, a lowercase q, or a capital Q, uppercase Q. So this vertical bar is like an OR. It is matching either this or this. So if the reply is a lowercase q or a capital case Q, then these commands will be executed. Program terminated, exit, and then close the case. And again here, if it is lowercase a or capital uppercase A, if it is lowercase b or uppercase B, do this. If it is lowercase c or uppercase C, then do this. And this is the wildcard pattern. It will match anything else. Anything else will be considered as invalid entry and exit with an error message. So let's test this program. display system information, lowercase a. Try it again, uppercase A, the same thing. Try it again, uppercase C. And try it again, lowercase q. So it is very similar to the program, the other many programs that we have done so far, but it just demonstrates the usage of case with the vertical bar, which is an OR, either this or this. Let's check this example, case for.sh. This is a test program that is testing a character. And the command read is taking this option -n1, which means read only one character and don't wait for enter to be pressed. So this is the prompt, type a character. As soon as we press a character, it is going to be saved to the variable reply, and the script will continue without pressing enter. We don't have to press enter. We just, with this echo, print an empty line, and then we case the value of the variable reply for the following cases. And if it matches an uppercase character, then echo reply is an uppercase. And notice that we are closing the case with double semicolon followed by an ampersand. And this means that the execution will continue with an ampersand. The execution will continue. So it will try to match the other cases as well. Usually, we use this double semicolon, and it means stop processing. We found a match. We did the actions that correspond to this matching, and stop processing, continue at the end of the case. The case command is finished, continue below it. But with this ampersand appended to it, it means that it is going to check the other cases as well. So it checked this pattern, it matched, but it is going to check whether the other patterns match as well. And here we have these character classes, lowercase, alphabetic, digit, graphical visible character. It is a visible character or a graphical character. It is a punctuation symbol, white space, hexadecimal digit. So let's try this example and verify that indeed for some characters, some characters will match several cases. For example, a letter can be an uppercase and alphabetic character. So it can be both of them. So it is going to match both of these cases. So let's type A. A is lowercase, A is alphabetic, A is a visible character, A is a hexadecimal digit. Let's try with capital X. As soon as I press capital X, it continues. It does not wait for me to press enter. X is uppercase, X is alphabetic, X is a visible character. Let's try, for example, with plus. Plus is a visible character, plus is a punctuation symbol. Let's try, for example, with question mark. is a visible character, is a punctuation symbol. Okay. Now let's see something else, some other topic. We'll see positional parameters. Let's see this example, which uses positional parameters, and try to understand what they are. So positional parameters are the arguments that are given to a script or to a command. And the first argument is stored by the shell to the special variable $1. The second argument is stored to the variable $2. The third argument is stored to the variable $3, and so on. And we will see what is this $0. And the number of arguments is stored in the variable $hash. So this contains the number of arguments. If there are three arguments, then this variable has the number has the value 3. So let's try to execute this, but without arguments. So I'm not passing any arguments. And we see that this $0 is the first word in the command line. So it is the command itself. And if I try, for example, with another path, so this is the current directory, then this $0 has the full path because this is replaced by the shell. It is expanded by the shell to contain the home directory and then this path as well. Examples. So it is the path to the current working directory. And if I pass some arguments, A, B, C, D, for example, then you see that the first argument is stored to $1. The second argument is we can find it inside the script to this variable $2, and so on. The third argument, the fourth argument, etc. And also here the number of arguments is 4. So we have 4 arguments, and it does not count the program itself. And in the previous cases, the number of arguments was 0. So the number of arguments does not include the program itself. It only counts the arguments that are given to the program or to the script. In case that we have more than 9 arguments, then we can use variables like this inside the script. So we are using these curly braces to delimit the name of the variable. Otherwise, if we don't use these curly braces, then it will be interpreted like this by the shell. So this is a special variable, the first argument, and it will append 1 to it, which is not what we want. So we have to delimit the name of the variable with curly braces in these cases. So it is not that we are limited to 9 arguments or to 10 arguments to the shell. We can give more than 9 arguments, but we have to specify the special variable like that for the 10th and 11th argument and so on. let's see this other example, positional parameters too. This example actually does a very similar thing to the previous example. It shows the number of arguments, but it does it in a different way. So let's try it first, and then we will try to understand it later. So posit params to A, B, C, D. And it is displaying argument 1 equal to A, argument 2 equal to B, argument 3 equal to C, argument 4 equal to D, and so on. It will continue if we give more arguments. So it is using a while loop to do it. And it is keeping also the count of arguments, a count of arguments, and count is initially 1. And now we are using this while loop, and this is the number of arguments. While the number of arguments is greater than 0, do echo argument count, and then this is the first argument. It displays the first argument. And then the count is incremented by 1. We have seen this before. And then it is calling shift. Now this shift is moving the arguments to the left. So the first argument is dropped, and the other ones are shifted by 1 place. So after it is processing the first argument, it is shifting the arguments. And so the second argument is becoming the first one now. And the third argument is becoming the second one, and so on. And then the number of arguments will be decremented by 1. It is checking the number of arguments here again. If it is still greater than 0, the cycle will be repeated once more. And then it will still print the first argument. But this is the first argument after shifting. So actually, the second time, it is the second original argument, and so on. So let's try it again. So this is how it works. So this shift will drop the first argument, and then all of this will be moved to the left. It is the same as this. So after the shift, it has these arguments. And then after the next shift, the first argument will be dropped, and so on, until all the arguments are dropped, and then the number of arguments becomes equal to 0, and the while cycle will stop. Because now the condition number of arguments is greater than 0 is not true. It will fail, and then the while is going to stop. Let's see this other example, file information.ssh. Now we are declaring a variable prog name, and then this is the 0th argument, which is actually the name of the program, and it includes the path of the argument as well. And this command base name is taking only the file name, so it is discarding the path from the name of the script. And and then it is assigning, this is being assigned to the variable prog name. Then it is going to check the first argument. Does it exist? The file, is there a file with this name? If there is such a file, or if first of all, if it fails. So if there is no a file with this name, then the else part will be executed, and then it will show that this program, it will show the usage. So prog name is the name of the program. Usage, the usage is after the prog name, we should give the name of a file. So it is expecting a file name after the program name as an argument. So it is going to display this to the standard error, this message to the standard error, and it will exit with exit code 1. But if the file exists, then we display this message, file type, and then we use the command file to show the type of the file. And then display the message file status, and we use the command stat to get some statistics from the file. And this option -e is making Echo to interpret this /n as new line character, not as a literal /n. So let's try this example. We get an error message, usage file info.sh file. So it is expecting a file as an argument. So let's call it with an argument. For example, we can use this file, which exists. And so since the file exists, it is displaying the message file type, and then this is the output from the file command. And then the message file status, and this is the output from the stat command. So actually, it is file statistics. So it is not file status, it is file statistics. Anyway, file status, file statistics, it is the same thing. And if we run, for example, this script by giving the name of the directory, for example, the current directory, then the command type gives this message, directory, and file statistics are giving this message. And if there is, for example, an argument with a file that does not exist, then it is expecting a file name. So we get an error message if such a file does not exist. This other script, file info fun, is very similar to this one, but in this case we are using a function. So we have this function, define this function file info, and this is what we this is the body, what we do inside this function. This is the body of the function. And then we are calling this function twice. Once we call it without arguments, and this is the message calling file info without arguments. And here we are calling it with an argument. And actually we are passing the name of this script itself as an argument, but it doesn't matter. It can be any file, but we are sure that this file exists because it is the script itself. So we are calling it twice. So file info, and we are giving this file name as an argument. And inside the function, again, the first argument given to the function is stored to the $1 variable. So this $1 inside the function is the first argument that is passed to the function. And $2 is the second argument that is passed to the function, and so on. So for the script, for the whole script, $1 is the first argument passed to the script. Inside the function, $1 is the first argument that is passed to a function. However, $0 is always the name of the script. And from the name of the script, including the path of the script. From it, we can get the program name using this command base name, which is removing the path part, and it is keeping only the name. And inside the function, this variable func name always contains the name of the function. So func name, in this case, has the value file info. Always the function, the variable func name contains always the name of the function. So let's try this script. Calling file info without arguments. In this case, it is displaying the usage. Calling file info with an argument, file info, and then $file. Then in this case, it displays file type, and then this is the name of the file, and then the command file shows what type this file is, and then file status, which or file statistics, which displays the statistics of or the status of the command. This is the last example for today, POSIT params 3. And this actually shows or demonstrates the usage of $* and $@. This $* contains a list of all the variables, all the arguments that are passed to the script. And the same for $@. It contains the list of all the arguments, but the difference between these two is that this is a string and this is an array. And it makes a difference. They are different. They give different results in some cases. So let's see how they are different. This function print params just displays the 4 parameters that are passed to it. So we are passing 4 parameters, or we are assuming that it gets 4 parameters. It may get 1 parameter or 2. The other ones will be empty. The 3rd and the 4th parameter may be empty. So it just displays the 4 arguments that are given to this function. Now the function pass params, it is passing some parameters to the function print params. And in this case, we are passing this $*, which is all the arguments that are passed to this function. And again, $*, all the arguments that are passed to this function, but surrounded in double quotes. And then the 3rd case, we are calling this print params, but we are passing it all the arguments that are given to this function with this $@. And in the 4th case, we surround $@ with double quotes. And also this message is showing us which case we are using. And finally, at the end of the script, we are calling this function, pass params, with 2 arguments. One is a single word, and the 2nd argument contains spaces, but it is surrounded by double quotes. So there are 2 arguments. One does not contain spaces, and the other one contains spaces. And let's see what will be the result of executing this script. So in the case when we call it $* without quotes, then we are passing 4 arguments, words with spaces, to the function. If we surround it with double quotes, then we are just passing 1 argument, a single argument. And in the 3rd case, we are using $@ without double quotes. Again, the function is seeing 4 different words or 4 arguments. The function is getting 4 arguments. The last case, when we are surrounding it with double quotes, the function actually is getting the 2 original arguments. So the first word and the second argument, which contains spaces. So it depends on the case that the script is being used. But in general, the most useful case is to pass all the arguments with this $@ sign surrounded by double quotes, because this preserves the original arguments. The other cases lose the original arguments that are passed to the script. So if we want to pass to a function all the arguments that are passed to the script, then the best way is to use this way. So let's stop for today.